All right, everyone. It is the last day of the challenge, and I actually can't believe how far we've gotten in just 7 days. So, for those of you that don't know, I'm following Angela Yu's 100 Days of Code. So, we've got all the challenges right here, and let's just recap where we started. So, we started with nothing. Over the first 3 days, we completed all the beginner assignments. Um, and then the next day we skipped all the way over to let's see, it's in our notes. Day 25, which is working with CSV data. So the basics of data processing in Python. The next day we jumped up to day 74, which was to merge data and do advanced analysis. And now we're going to take on the final boss for data science, which is a professional portfolio project. Um, yeah, let's go ahead and do this one. I think space is more interesting. Um, but I can't believe how far we've gotten. I really hope that I'm ready to take on this challenge. I think there's a good chance that I am. So let's dive into it, and I'll actually show you. So we're using space mission data from 1957 onwards to analyze trends over time. And I think just from the minimal training that we have, we can actually do some pretty impressive stuff pretty quickly. So there's a data set from next space flight. Let's see. Includes all space missions, has data on mission status, cost, number of launches per country, and more. Let's just see. Oh, cool. So it's actually got a starting file, which is way better because I did not know where that data set is. Let's go ahead and open that up. And what we actually want to do is create a new project. We're going to call it Space Missions. Or actually, we're going to call it Day 99, almost the last day in the challenge. Day 99. Day 99, space analysis. We'll just do day 99. And we'll leave that to comments. And we want it in a new window because I'm going to be referencing some of this code. This is a lot of advanced pandas stuff, a lot of Plotly or Matplotlib, which is the way that you kind of display your um, how you display any data that you have. So let's go ahead and start. Oh, it's a Jupyter. Can I open that in here? I don't know what this is. Nextplaceflight.com. Oh, whoops. So let's just look over the book. This is the full assignment. I think I'm gonna have to unzip this. So let's go into downloads. Let's take this. And actually, I think this is what I want to do is I want to, let's actually just go in. Let's take this, copy it, and then let's find the path for day 99. So we'll open that. Day 99. Let's just refresh that. So file, let's open recent. Oh, here we go. Oh, it didn't open it as a Jupyter notebook or whatever. So that sucks. Okay, let's just go ahead and open it from the source then. So we'll go in and we'll open it. Whoops. Here we go. And you can see this is the data set. So you can see, let's go ahead and actually just do this. Oh, you can't do anything without a license. You can see status, you can see, I'm guessing that's the cost in millions. Probably. 50 million for the first one, 20 million, 145 million. So a year. Yeah. So that's going to be really cool, actually. There's a lot we can do with that, in my opinion. So let's go ahead and run this. We're just going to move forward. Hey, Yosef. It right now it is it's 5 in the morning. Almost 6. Oh my gosh, I did it again. Dang it. I've just been streaming myself um for the first 9 minutes. That sucks. So I guess I'll go ahead and show everything again. Um so this is where we're at on the challenge. For context, I've been doing the Udemy 100 Days of Python challenge. And to learn it faster, what I've been doing is just cutting out the data section. So in the first 3 days of this challenge, we did the first 15 days. And then we went straight to day 25 to work with CSV data. Then we went to day, I think 70 something. Yeah, 74 was advanced data analysis with the Lego dataset. And now we're taking on the final challenge, which is a professional project. So we should be we not good on that. Oh, we had to select the kernel. Okay, cool. Ran that. Let's upgrade. And so this is all the basic configuration that we're going to do. And I guess I can show you the data set since that didn't go through either. So while that's loading, this is the space data set that we're going to be analyzing. 4,300 launches. Organization, SpaceX. So we can actually see if SpaceX is the cheapest. We can't actually expand this to show the date, but we have details on the rocket. We have the status. We have mission, impact, organization, unnamed. And just an index, which is crazy because this index counts all the way up to 4,323. So there have been a lot of rockets sent into space. What we're going to be doing is, oh my gosh, it's taken a while. Oh, that's why. What if I just do that? Cool. Okay, so this is just formatting the notebook. Let's check the chat. I record in the morning. Yeah, this is really just the only time that I get. So let's go ahead. Now we're going to read the mission launches CSV. And that took no time at all. So preliminary, whoops. What is the shape of DF data? Print. Is that a thing? Let me see if that's a thing. I think it's actually dfdata.shape. Yep, okay, 4,324 by 9. How many rows and columns does it have? What are the column names? Can I do that? DF data at index 0. I don't think that's actually going to work. But we can just do df data dot head. That's not right. That's going to sort it. But location, Kennedy Space Center, Launch Center. Yeah, I don't really get the. I mean, organization matches up. Unnamed should match up because if you look here, I don't think that was what it was like. I think it organization, location, date, detail, rocket status, price. DF data, there's got to be a thing to just get the headers. What about this? So let's check that out. Data dot columns dot values. Let me go ahead and try to fix that. So we're going to go into space missions. We cut it all out. Whatever. I guess that's not a big deal. Um, that's another thing. Why is it? I guess I can just open it in here. Okay, so let's just save this real quick. Oh, okay. Let's see. So then what we're gonna do is we're gonna create the data frame, but we're actually going to drop um, the entire column named so we're going to drop that, and then we're going to so let's go ahead and drop that. Oh, whoops. We need to say that it is a column. Access equal, oh, here we go. Unnamed 1. Okay, so we remove that, and now when we print the headers, we have unnamed 0, organization, location, date, detail, rocket status, price, and mission status. So I think that's good, honestly. So descriptive statistics. The interesting thing is you're not even pairing connections between data. Like day 74 actually got more advanced than this did. This is just less help that you get. So I don't even know what this is asking for, descriptive status. Create a chart that shows the number of space mission launches by organization. Okay, so let's do it this way. We want a bar chart, right? So let's go into here. And what we're actually going to do is we're going to open up our old code because we did a bar chart. And the first thing we're going to do is, let's say num. That's really, we need to sort by organization and count and then on the bottom we want organization name, on the top we want number. Okay, so let's see how we did that in the old one. Set data, sorted. Oh, here we go. Probably gonna be this. You want to group by year. Although in this one, we want to actually, we'll say, or we'll do, okay, so for the number of launches, I'm in the wrong thing. So sort organization by count and unique values. So we want to say, um, launches by org. And we're going to set it equal to df data dot, and we're going to group it by organization. Just want to make sure I spell it right. So we're grouping by organization, and then we are going to aggregate so we're going to aggregate the data based on the number. I think it is just in unique. I don't think that's actually what I want. I think I just want this. Organization dot in unique, and then I'm going to say print. Launches by org. Let's run that. 56. No, so it is. I do want to aggregate. Okay, so we are going to group by organization. Organization. And then we're going to and we're going to aggregate all this information for We're going to aggregate the organizational information. And we're going to do OPD. PD series and unique. And let's just see. So what am I trying to do? I'm trying to go through each unique organization. I don't want in unique. I want count. So for each organization, we want the count. Okay, and then let's think about this. We don't want the um so it's got to be somewhere in here. Okay, so here we go. Let's see, PD series dot count. So here's what I think we want to do. We're going to say launches by org. DF data. And we want the data of the organizations. Dot value counts. There we go. That's what we want. That's really all we need. And then let's just print the top 10. So we can do that. What I'm going to do is actually just throw in some of this information. Okay, so we want a bar graph of the data, and for the x-axis, we want the name, which is going to be organization. So and we only want the first, let's say 5. Okay. And then we want, on the index, we want it to be the count. Let me go ahead and run this. So actually I do have to, because there's no name on this. So we actually want to set let me see the last time I did value counts. Let me see if just index works. Okay, so organization. Let's get rid of the dot. Let's run this again. We want it to be It's not index. So it is dot index. Okay. So what I need to do is set launches by org is equal to data frame where columns equal organizations and what? So it is index. Okay, so that's the thing. This needs to be launches by org dot orgs. And we'll just spread out the first 5. So let's run that. There we go. Let's just print the index. Why is this so bizarre? Oh, is that all it is? Okay. Watch this. So we're going to do index and we're going to do values. And we're going to go up here and we're going to not do this. Let's print the values. Okay, so we have that. And then, so now we're going to plot it and it should work. Cool. So you can see that Russia has put out a whopping over 1,750. And then where NASA has only put out about 200, General Dynamics, all the other organizations. Let's go ahead and do 10 just to give some more context. So watch this. Let's run that and you can see. So Russia put out a ridiculous amount. And then it slowly trickles down. The Air Force has put some out. Wow. General Dynamics. And that's crazy that SpaceX isn't even in the top 10. So number of active and retired rockets. So the easiest way to do that would be if we pull this up, there is a status. Let's scroll up so we can get the variable name on that, rocket status. And it's either status active or probably status retired. Yep, it is. So to get that, what we want to do is we want to say df data we'll say rocket status is going to be equal to the data frame dot rocket status dot value counts, and then we'll go ahead and we'll print rocket status. That will give us, cool. So we did that in one line. How many missions were successful? How many missions failed? So that's actually just mission status. So we can do, it's literally just going to be this line. But what we want to do is instead of rocket status, we want to get mission status. value counts and then print that. And then we want to print mission status. Pre-launch failure, partial failure, success failure. I don't even know what this means. I'm guessing that means they never launched, and that means that maybe they had to turn around. And this one means, like, I would think they exploded or something. That would be my thought. Hey, this is the so I'll show you just for context. This is day 99 of it's the final project of the space race. You go to nextspaceflight.com and that gives you a data set. I just have it right here. But they have a ton of data about space information here. And I don't actually know where the data came from, which is the only kind of funny thing. But yeah, I just got it from a spreadsheet is how I got it. Let's see. I'll go ahead and throw it in the comments if you're interested. Nextspaceflight.com. Here we go. Oh, there we go. Okay, so mission successful, mission failures. So then create a histogram, visualize distribution. We should have column given in millions. Careful of missing values. Let me see. Millions of dollars. I don't even know what a histogram is. Let's go ahead and search that. Let's see. There we go. Histogram depicts frequency distribution of variables in a data set. So it's going to be year and it's going to be average cost. Cool. Okay, so let's go ahead and do that. How expensive are the launches? So let's say price per year. We're going to sort by year. So here's what we need to do for that. We need to sort by year. and filter by price. Um, removing values. And then we also want to that's price per year, but we also want to, let's just display it as a histogram. Let's say average of every 5 years or something. In US dollar millions. First, let's go ahead and take some of this. So you don't need any of this. The X label we want to be years. And we want this to be cost. Cost in millions. And we do want a histogram. And only give it an X value. That's interesting. Let's go ahead and just search the documentation on a histogram real quick. Let's just see what it shows. That's interesting. Okay. The price column is given in US dollar millions. Okay. Oh, this is going to take way more than a day. So let's see, price per year. Price per year. Dot. And we want bins to be equal to price per year dot index over 30 or something, right? And then this, we don't want it to be index. We want it to be, I think. So let's actually get that information. Sort by year and filter by price. So we want to sum So we want to create a data frame or access the data frame's data. And then from the data frame's data, we want to sort values by year. Let me just make sure that's what the variable is called. Date. Ah. So it gives the exact time, which I just need the year. Let me see if there's a year column. There is not. So I'm going to have to somehow reformat. Let's say Ooh, that's weird. Pandas, let's say change. Uh, let's say, here's what we actually want to do. Okay, let's see if this works. There's no way they applied. Oh, they did apply date time. So then here's what we want to hopefully do. So we want to take the year and we want to apply df data is equal to df data. We want to say is that what it is? Date? Yeah. Date is equal to df data. So it's pandas dot to date time. Df data. And then let's go ahead and print the data frames data. Let's run that. String. So let's see, what would we need to... Friday, August 7, 2020. Yeah, this is shouldn't be difficult. Let's see if I can strp time or whatever it is. Format. Um, so let's go back to this. Friday, August 7th. So Friday, month. August 7th, so day. One 33. So Friday, August 7th, and then here's the year. At hour, a minute. So it's going to be percent I percent M percent P. Let me see. Daytime and time delta. I want to see. I found a resource where someone else did this. Wait, what? Oh, that's ridiculous. It's not by years, it's by organization. Okay, this doesn't make much sense, but it needs. So bins, let's just do like 5. Density. I think it's called ascending is equal to false. It's actually a list for each dimension. So there we go on that. And then I'm cheating on this for sure. I know you could just sort. Organization. Does that work? Invens. Okay, so it's definitely a problem with that. I don't think it's a density issue, but try that. So DF data, sort values by organization and price. Got multiple value arguments. So what it's called is price. Yep. Oh, there we go. I thought that would fix it. Let me see if this works. So that doesn't even work. Total amount of money spent by organizations on space missions. Total. I guess if there's an error, nothing gets suggested. I just want to see if this works. df sort values. Um, Whoops. Yeah, it actually kind of sucks to do this without a suggestion. Hmm. Shoot, I really gotta start getting ready. Well, maybe I'll keep going later on today. So thanks for watching. I will see you tomorrow.